Okay, chapter 2, day 3. We've simplified, we've multiplied, we've divided. Today what we're going to focus on is how do we add and subtract rational expressions. You did this also when you took Algebra 1, you did adding and subtracting. We're going to start out some basic adding and subtracting, but very quickly it gets into more difficult types of factoring, and that's what kind of moves you beyond Algebra 1 into Algebra 2 trig. Concept is the same though. The concept is not going to change from what you learned in Algebra 1. Okay, so first of all, let's recall some rules for fractions. In order to add or subtract fractions, we need to have a common denominator. We cannot add or subtract fractions that have different denominators, all right? So the common denominator is if we're working with numbers, is a number that is at least as big as the biggest number. So 7, at least as big as 7. Does 5 go into 7 evenly? No. So now we have to find a number bigger than 7 that both 5 and 7 can go into. The easiest way to do it is to take your biggest number and think of multiples of the big number. And then, does 5 go into that? So, 7 and 7 is 14. 5 doesn't go into that. 21, no. 7 times 4 is 28, no. 7 times 5 is 35, and I know 5 goes into it because it was 7 times 5. So my common denominator for this problem is going to be 35. Now, if you remember back, I mean, you've been doing this since, I don't know how long ago, but we have to make the denominator say 35. So we're going to multiply here by what makes this 7 times what is 35? Well, that's a 5. And we have to do that on top and bottom. And 5 times what is 35? Well, that's 7. Multiply that. And so hopefully this is a really recap and review from probably about 3rd grade. You've been doing fractions. So hopefully this isn't brand new to you. Now, 5 times 3 is 15, okay, plus 7 times 1 is 7, all over my common denominator of 35. 15 plus 7 is 22 out of 35, and then I look, can I reduce? Is there anything that can go into 22 and 35? In this case, no, so that would be my answer. So again, you have to have a common denominator in order to combine fractions, whether you're adding or subtracting, okay? Now, in Algebra 1, you worked with problems that had x's on the bottom, all right? So same thing. First, find a common denominator. The first step, find a common denominator. So, if I have numbers and letters, everything has to be represented in my common denominator. Okay? And so if there's a letter, I have to have the letter in my common denominator. All right? If it is a letter to a power, I have to have the largest power that I see in my common denominator. All right? So I have an x. I have to have a 7 represented in my common denominator. Okay? If this was a binomial, 2 terms, I would need both of those terms together in my common denominator. You did this in Algebra 1. All right, so now, step 2, multiply each term. So this is a term that is separated by plus sign, and this is another term, okay, by what is missing to get the common denominator in this denominator. So I look at the x. I look at x times 7, and I say, okay, what does this have that this does not have? What is missing? What's missing in this one is the 7. So I'm going to multiply the bottom times 7, so that way 7 times x is 7x. But to be fair mathematically, I have to multiply the top as well. So I multiply each term by what's missing, and I have to multiply the top and the bottom, because really this is still multiplying by 1. Okay, what's missing here? Well, it has a 7, this has a 7, but it's missing the x. So I multiply by x. All right, so to be fair, top and bottom. All right, now rewrite as one fraction with the common denominator. So just like I did up here, once I get to this part, I rewrite it as one fraction all over the common denominator. So 7 times 3, 21, plus 4 times x, 4x, all over the common denominator of, what's right here, all over 7x. Okay? So, find a common denominator. Everything has to be represented. Multiply each term by what's missing to get the common denominator. Okay? Rewrite it as one fraction. And then the last thing you need to do is to reduce if possible. Well, that was yesterday and the previous day's lesson. That was day 1. Factor and reduce if possible. Well, there's nothing to factor on the top, so I can't reduce. I can't just cross off the 7 and the 21. I can only reduce if I factor first. When I have a binomial or a trinomial, I have to factor something out in order to reduce it. So that one is done. Okay, so let's take a look at the next problem. All right? So my common denominator. Well, I see 6 and 3's. This is not a binomial because it's just one term. So it doesn't have to stay as like 3 plus x. It's not. It's just 3x. All right? So I look at the 3 and the 6 and I say, what's a number that they both can go into at least as big as 6? In this case, the answer is 6. They both go into 6. X is here. I got to have an x represented. All right, step 1 done. Step 2, multiply by what's missing. So this is missing the x. And this has a 3, but what do I multiply to get 6? That would be 2. And it has an x, so I don't need to do anything else. Because if I multiply 3x times 2, I would have my common denominator. Okay, so step 1 is done. Step 2 is done. Multiply each term by what's missing. Step 3, rewrite as one fraction. So now I have to do some multiplying and rewriting. So 5 times x, that's 5x, plus 2 times 2 is 4, okay, all over 6x. So 5x plus 4 over 6x. I cannot factor anything out of the top, so therefore I cannot reduce. I can only reduce if I can factor. Okay, they progressively get a little bit harder. Notice this next example. On the bottom now, I have binomials, and I also have some quadratic pieces. When I see a quadratic, an x squared, I have to factor if possible. All right, I have to look to factor when I see x squareds. Or if I see any kind of GCF that I can take out, I need to factor that out. So even before we begin, I have to take a look at this bottom a little bit closer by factoring. So x squared minus 4, x plus 2x minus 2. Okay, so now, common denominator. Well, I have an x minus 2. That really is a group together that has to stay together. I don't put an x and then I don't put a 2. This is paired up together with a plus, with a minus sign, but anything with a plus or minus sign you have to leave together. All right. Now over here, I have an x plus 2. Well, I need something like that, x plus 2. I don't have an x plus 2. An x minus 2. I have one. I don't need to write it again. So everything is represented out of the bottom. So now, again, step 2, what's missing? Okay, x minus 2, got it. Ooh, I'm missing an x plus 2. Okay. Over here, x plus 2, got it. X minus 2, got it. It's not missing anything, so I don't need to multiply this one by anything. Just lets it ride. But I do see that this problem is a minus problem. All right? And so, just like you did in Algebra 1, if you had a minus situation, my tip would be to make this plus and change the sign on every term after it. That way, now I'm back to addition. So when we think about the focus, which was how do we add and subtract? Subtraction, all we're going to do is change the sign in the middle to addition, change the signs of every term after it, and now we're back to addition again, and now it's no different. Okay, so step 1, let's see what we did. We found a common denominator. We multiplied each term by what's missing to get the common denominator. Now we're going to rewrite it as one fraction. All right, so we got to rewrite as one fraction. So, I got to do some distributing. So 6 times x, 6x. Plus 6 times 2 is 12. Plus a negative x. And so I could have written that as minus x, or I could do plus a negative x, it doesn't matter. And then plus a negative 1, I'll just write as minus 1, it's no big deal. All over my common denominator of x minus 2, x plus 2. So, rewrite as one fraction we did. Reduce if possible. So now I got to take a look. Maybe it's reducible. I don't know. Okay? So I have a 6x, take away an x, that's a 5x. 12, take away 1, that's 11. I can't factor anything out of the top, therefore I can't reduce. And therefore, I'm done. There's one more problem we're going to look at, but I'm going to do that one in class with you. It's a little bit more involved. And so when we start class, next class, instead of a warm-up question, we're going to take a look at the next notes question, and we're going to work through it together as like our warm-up. Okay, so that's chapter 2, day 3.